Hey everyone, this is Miss Scott. So I know that there have been some power outages due to the storm last night. And so if you happen to not be able to come to class today, I'm going to put together a little screencast here, just kind of tell you what we did and to go through the notes at the end. Okay. So our goal for today is going to be to learn about how to use molar ratios to convert between moles of the substances in a chemical reaction. And you're going to have one piece of homework, and that's going to be due if you are in periods 2 or 6. That's going to be due on Friday at 9:30 in the morning, and that is this handout right here. Okay? It looks like there's a lot, but I promise you the math here is actually simpler than what we've been doing. So that is your piece of homework. You can find it on Canvas here. Okay. Our slate is also posted here, so you can look at kind of ahead for the week, what we'll be doing on Friday. And then the slides are here if you want to open them up on your own. Okay. And so first thing we're going to do is just check our homework for grams to particles, but we'll start with one announcement, which is that you are going to have some retakes, opportunity for a retake for our Unit 4 quiz, okay? And that is going to be Friday. It's going to be asynchronous, anytime between 9:30 in the morning and 11:59 p.m., okay? If you would like to take it during office hours with with a teacher, you'll need to take it with Mr. Sohal. I unfortunately am not available for office hours for this class on Friday, but he is a great teacher. If you want to take it during that time, if you know you're someone who's likely to have questions while you're taking the retake, then you can always go to his office hours. I'll post something on Canvas so that you can do that. Your quiz is available on Canvas, so you can take a moment and look over it. I also included our grade scale here just to remind you that we have a slightly different grade scale for chemistry. And so take a look at your score and take a look at what that means for your grade. The max retake score that you can get is 80%, which is about 13.6 out of 17, okay? So if you're in that C or D or F range, definitely a retake is a great idea. If you're somewhere in the B range, maybe just give yourself a break and focus on doing better for the next quiz. So this is what we've been talking about thus far. We've learned about Avogadro's number, we've learned about molar mass, and on Friday, we talked about how to put these two pieces together, okay? And your homework was to put these two tools together to convert from grams to moles using molar mass, and convert from moles to particles using Avogadro's number. Okay, so I'm going to show you the keys for your homework. You can pause the screencast at any point if you want to correct your work. Okay, but we're correcting our grams to moles to particles practice. And a couple of things that I've noticed in looking at people's work is, one, if you get any answers that happen to be very large, so if you get something times 10 to the 40 something, likely what happened is that you haven't put things into your calculator correctly, okay? And particularly if you got any numbers that are times 40 something for part B, okay? The other thing is that for number 3 and for number 4, they talk about formula units. And if you remember, basically formula units are just a type of particle, but for ionic substances rather than molecules, which we use for covalent substances. Okay, and so when it asks for the number of formula units, or it gives you a number of formula units, you can just think of that as particles, okay? And anytime we have particles, we can use Avogadro's number. Okay, so for each of these, you should start with what you're given. For B, on all of these problems, you're using molar mass and then Avogadro's number to get your answer. For part C, for all of these, you're using Avogadro's number and then molar mass to get your final answer, okay? And so let's take a look at the next one, at baking soda. Notice here that everything is labeled with a unit and with the substance that it is, okay? At least most of the time. And I've crossed out the units as they cancel out, okay? So notice here that grams is going to cancel out with grams, moles is going to cancel out with moles and leave formula units. Here, formula units is going to cancel out, moles is going to cancel out, and I'm going to be left with grams. And here's our last one for sugar. Looking at molecules, sugar is a covalent compound, which is why we're looking at molecules and not formula units. but the process is very similar. Now, if you got very slightly different answers because you rounded differently, that's okay. If your answers are really far off, then take a look at your setup and see maybe where you went wrong. And if your setup looks correct, then my guess is you probably typed something in your calculator incorrectly, okay? So if you have questions on grams to particles, please make sure that you come and talk to me during office hours today. We can go through an example or two. But we're going to learn about one more tool today in order to get ready to kind of put all of the tools that we're learning together into one kind of new idea. Okay. So during class, we're going to do a check-in. If you are not able to make class today because of the power outage, don't worry about it. It's just a short little check-in about kind of what we've been learning thus far. Okay, but here is where we are going. We're going to look at how we can use the process of dimensional analysis to do calculations for chemical reactions and how we can determine how much product can be made in a reaction, how much reactant do you need to start with for a reaction, how much is left over at the end of a reaction. That's where we're going, and that's really where we're going to pick up on Friday. But when we look, kind of these general calculations are called stoichiometry, which is sometimes something people have heard before they start chemistry. And so we're going to get our last kind of piece today in order to be able to do these calculations on Friday. So during class, we're going to do a little group activity, kind of just thinking about making grilled cheeses. If you want to take a look at your period's slide deck, you're welcome to do that. But it's a little intro activity, just kind of thinking about putting together a recipe and having a product, and how do we determine how much we need of each ingredient to make a certain number of each product. Okay, and so you can look through, this is just kind of an intro activity to get us thinking about what is the idea of relationships and ratios between ingredients and products, or reactants and products. Okay, and these are the answers to that kind of group warm-up. And so why did we start off class with this? Well, if I think about making a grilled cheese, so 2 slices of bread, 3 slices of cheese, and 1 tablespoon of butter, making 1 grilled cheese. What does this have to do with chemistry? Well, this kind of is somewhat like a chemical reaction. And therefore, we can kind of start to see here the way that we have relationships between ingredients and a final cooked product. We also have relationships between different chemicals. Okay, so you can use this chemical reaction to relate the ingredients together. Every time I have 2 slices of bread, I can make 1 grilled cheese. Every time I have 3 slices of cheese, I can make 1 grilled cheese sandwich. If I had 5 slices of cheese, I can only still make 1 grilled cheese sandwich because I need 3 slices of cheese for each sandwich. And so we get these kind of relationships, such as kind of down here, that help us to think about how these ingredients are related to each other. And this has a specific name in chemistry. This is the idea of mole ratios. Okay, and so this is what we're going to talk about today. So when we're looking at chemical equations, we can see the same types of relationships. They're just going to look a little different because they're not going to be talking about cheese and butter and bread. So main thing you need to make sure you do today is take some notes, okay? So our essential question is, how can we use balanced chemical equations to determine the molar ratios of reactants and products in a chemical reaction? So what I'd like you to do is title the top of your page and write down the essential question at the top and draw a line. Pause the screencast here so you can do that. Okay, so a balanced chemical equation gives the relative numbers of molecules or reacting particles, so atoms, ions, that participate in a chemical reaction. So here's an example of a chemical reaction. Okay. So this is our chemical equation. We've been practicing balancing these and identifying the type of reaction. You may notice that this is a combustion reaction. Okay, right? We see CH, we see O2 as a reactant, and CO2 and H2O as products. And so I can kind of read this out of this equation, thinking about how many molecules are actually a part of this reaction. So 1 molecule of propane, which is C3H8, reacts with 5 molecules of oxygen to produce 3 molecules of carbon dioxide and 4 molecules of water. Okay, my coefficients here are going to represent the ratio of individual molecules of reactants and products. They tell me, much like 3 slices of cheese makes 1 grilled cheese sandwich, they tell me that 5 molecules of oxygen will produce 3 molecules of carbon dioxide and 4 molecules of water. Okay, and so these coefficients represent the ratios of reactants to products. However, they also represent the ratio of moles of molecules. Okay, and this is a really important thing. If I think about actually all of my coefficients, rather than representing one individual molecule, but a whole mole of molecules, this becomes a much more powerful ratio to use. It allows us to actually be able to determine how much reactant will be needed to complete a reaction or how much product can be made. Okay, and so if we actually look at, instead of this as just one molecule, we can say, well, what if I converted 1 molecule, 5 molecules, 6 molecules, and 4 molecules all to moles, just by multiplying everything by 6.202 times 10 to the 23rd. And so now my ratio instead reads 1 mole of propane and 5 moles of oxygen react to create 3 moles of CO2 and 4 moles of water. And so this is really important because we don't actually deal with chemical reactions on an individual molecule or formula unit or atom basis. We're dealing with everything in terms of moles, right? We've been working on practicing calculating the number of moles based on the number of grams or the number of particles, and that's because moles is a really useful unit for us to use to be able to compare different substances to each other in a chemical reaction. Okay, so the coefficients show how the reactants and products are related to each other. So if I were to look at this, I can say, for example, 1 mole of C3H8 will produce 4 moles of water. That's really helpful. So if I know that I have 2 moles of C3H8, I know that I'm going to produce 8 moles of water. Okay. And so let's practice a little bit determining the ratios between reactants and products. And so we're going to do this by looking at the coefficients in front of my substances in my chemical equation. Okay, so you can pause and do this and then kind of hear the answers as we go. Okay, so take a moment, maybe pause, try and fill in the answers as you see fit, and then we'll go over them. Okay, so here I'm looking at moles of C3H8 will produce moles of CO2. So I'm going to see no coefficient here, so this really should just be a 1. And so 1 mole of C3H8 will produce 3 moles of CO2. Okay, here I'm looking at how many moles of O2 will produce how many moles of H2O. Here I see a 5, here I see a 4. So 5 moles of O2 will produce 4 moles of H2O. Moles of O2 are needed to fully react with moles of C3H8. You can have relationships between reactants or between products. They don't have to be a reactant to a product relationship. So I'm going to need 5 moles of O2 to fully react with 1 mole of C3H8. And for our last one, looking at moles, we'll produce moles of O2 will produce moles of CO2. I've got 5 moles of O2 will produce 3 moles of CO2. Okay, so these are mole ratios. Okay, they're molar ratios between reactants and products in a specific chemical reaction based on coefficients. Okay, and so that's really important that you note, 1, kind of what a mole ratio is. Here's a nice little definition. And 2, that these are specific to a chemical reaction. Okay, oxygen and CO2 and H2O show up in a lot of other chemical equations, and they don't always have the same relationship of 5 to 3 or 5 to 4, but they do for this specific chemical reaction. Okay, so our mole ratios are specific to only the chemical reaction you are looking at. That's not true of Avogadro's number, which is true for everything, and molar mass, which is just specific to that compound. The molar mass of H2O is always 18.02 grams per mole. It doesn't matter what water is reacting with, it's always going to be the same. Okay, but mole ratios are dependent on the chemical reaction you're looking at. So if you did the intro, or just kind of looked through it, if you did it using dimensional analysis, which probably you didn't, you can actually kind of see that these are basically mole ratios in our introduction. Okay, you're thinking about the relationship between reactants and products. Okay, and so why are mole ratios useful? Because they are conversion factors, right? And that's what we've been working with the last kind of week and a half. So we've been thinking about different things as conversion factors, and mole ratios are simply conversion factors between moles of different reactants and products in a specific chemical reaction. Okay, so let's look at a different reaction. We've got N2 plus 3H2 goes to 2NH3. Okay, so this is the synthesis of ammonia. That's what NH3 is. And so if you want to convert between moles of N2 and moles of NH3, so we can actually say, well, I know that 1 mole of N2 is going to produce 2 moles of NH3, right? We were just looking at that, looking at our coefficients to determine the relationship between two substances. But this is not the most useful form of this. In reality, I can write 2 conversion factors from this relationship. I can either say that 1 mole of N2 over 2 moles of NH3, or I can say 2 moles of NH3 over 1 mole of N2. And these conversion factors actually allow me to look at a number of moles of N2 that I have and determine how many moles of NH3 will be produced, or to look at a number of moles of NH3 that need to be produced and determine how many moles of N2 I need to start with. Okay, so you can think of this as either if I have this many ingredients, how many grilled cheese sandwiches can I make? Or if I need to make this many grilled cheese sandwiches, how many ingredients do I need? Okay, and so let's go through an example or two. So we can use these chemical equations to determine how many moles of reactants or products are used or made in a reaction, and then we can use that in order to actually solve our problem. So, for example, if you react 4.3 moles of N2 gas with hydrogen, how many moles of NH3 will be produced? So what am I given here? Well, I'm given I have 4.3 moles of N2. Okay, and I want to find moles of NH3. So you should make sure that you get this example down in your notes, and feel free to pause at any point when you need to write something down or if I ask a question. Okay, so I'm going from moles to moles, and because I'm going from moles of one substance to moles of another substance, I need to use mole ratio as my conversion factor. And so I have here two conversion factors that I could use. Okay, I've got 1 mole of N2 over 2 moles of NH3, and I've got 2 moles of NH3 over 1 mole of N2. Okay, so if I look at my chemical reaction up there, I got those numbers right from the coefficients in my chemical equation. So now I need to determine which one to use. So you can pause, think for a moment, which one of these should you use? And if you said you're going to use the right one, that would be correct. Now, why am I using the right conversion factor, this conversion factor? Because moles of N2 needs to cancel out with moles of N2, and those two are going to be, that needs to be on the bottom so that these two cancel out. I'm left with moles of NH3, and that's the unit that I want to have. And so simply all I need to do is multiply 4.3 times 2 to get 8.6. Nice thing about mole ratios is they're nice whole numbers, and the math tends to be pretty easy to actually calculate as opposed to using scientific notation. Okay, so here's another example that you can try on your own. So take a moment and try and set this up, and then I'll talk through the answer. Okay, so hopefully you had a chance to set this up. Okay, so we have, if you react 0.45 moles of H2 gas with nitrogen, how many moles of NH3 will be produced? Well, what I'm starting with here is 0.45 moles of H2, right? And I want to know how many moles of NH3 are going to be produced. So again, we're going from moles of one substance to moles of another, and so we need to use mole ratio. Okay, and so I'm now, instead of looking at N2 and H2, I'm looking at NH3, I'm looking at H2 and NH3. And so I see 3 and 2, and so that's going to help me build my conversion factors. And so I see I can either do 3 moles of H2 over 2 moles of NH3, or 2 moles of NH3 over 3 moles of H2. It is really important here that you do write moles and you don't just say 2 NH2 and 3 H2. Okay, so please do make sure you include mole as a unit. And so you can kind of think for a moment, which one do I need to use? Well, I'm given that I have moles of H2, and so that means that moles of H2 needs to be on the bottom in the denominator. And so moles of H2 is going to go on the bottom so that those two cancel out, and moles of NH3 is going to be on top so that that's what I get out for my final answer. Okay, and so now all I'm going to do is do 0.45 times 2 divided by 3, which is going to be 0.3 moles of NH3 produced. Okay, and so this is mole ratios. This is what you're going to kind of do for homework. Okay, so what are our steps? Our steps are identifying what you're given and identifying what your goal is. Okay, and then you're going to determine which conversion factor, which tool you're going to use to convert from the units you're given to the units of your goal. Set up your dimensional analysis, cancel out your units, and then simply calculate. Okay, make sure you include units and labels for your final answer. And so what you should make sure that you do right now is once you've kind of finished up your notes, below your notes you can start this practice, okay? And so one thing to note is that you have a couple of different problems, and each of them have a sub problems. The A, B, or A, B, C, D all have to do with one chemical equation, okay? And so you need to make sure that you balance your chemical equation before you get started, okay? So if you notice right here, some of them are definitely not balanced, okay? So make sure that you balance your chemical equation before you start solving your problems, okay? You should show all of your work just like I did for our last example. So something like this looks great. You don't have to do the 2 conversion factors at the bottom. Just make sure you have some nice dimensional analysis set up. Okay. If you have questions, you can come on into office hours today, if possible, or you can send me an email. Okay. Hopefully I will see all of you on Friday. Have a good rest of your day.